Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to continue in our book of air conditioning system. And this is the chapter 11. This is the chapter dedicated to the sizing of the air conditioning equipment, the calculation, the grills, the ducts. Yes, we are going to use a couple of formulas, a couple of tips that I recommend in order to select the appropriate air conditioning unit for your boat. Right now we know the difference between a self-contained unit, chiller unit, a split unit, and right now we are going to take other considerations in order to select the air conditioning unit appropriate per each boat. In order to start, we are going to refresh a couple of basic concepts that you need to keep clear when you try to select an air conditioning unit. One of the most important part is the units. The units used in the industry, in the market, for air conditioning units. And the most common unit is the BTU. What is the meaning of a BTU? It's a British thermal unit. It's basically the amount of energy required to rise the temperature of 1 pound of water 1 degree Fahrenheit. Yes, it's how much energy is required to rise the temperature of 1 pound of water 1 degree Fahrenheit. This is a BTU. This is 1 BTU. It's basically a unit of energy. Some industrial manufacturers of air conditioning equipment for residential application and industrial applications, they prefer, instead of BTUs, they prefer tons. And yes, basically 1 ton is equivalent to 12,000 BTUs. Try to keep in mind that conversion. 1 ton is equivalent to 12,000 BTUs, and it's easy to convert BTUs into tons. In industrial application, in residential designs, they use, instead of BTUs, they use tons of refrigeration. But at the end of the day, doesn't matter if you calculate in tons or BTUs, you can convert easily, because 1 ton is equivalent to 12,000 BTUs. Alright, 1 BTU is the amount of energy to rise the temperature of 1 pound of water 1 degree Fahrenheit. Okay, you can consider BTUs or tons. That is equivalent. And yes, we are going to use other simple formulas to convert. Don't forget that 1 horsepower is equivalent. 1 horsepower is equivalent to 746 watts. 1 horsepower mechanical power is equivalent to 746 electrical power. This is the same like 1 kilowatt is equal to 0.74 horsepower. It's the same. Alright, my friends. Another important combination is 1 kilowatt. 1 kilowatt is equivalent to 3413 BTUs. 3,413 BTUs. 1 kilowatt hour is equivalent to 3,413 BTUs per hour. And 1 ton is equivalent to 12,000 BTUs. It's the other conversion. We don't need more conversion. And right now we are going to start with the procedure to calculate, to select the appropriate air conditioning system. If you check other engineers dedicated to study air conditioning units, air conditioning system, refrigeration systems, there are a lot of methods to calculate appropriate the unit of air condition for that area. I check in different authors, different books. There are a lot of formulas, a lot of techniques to calculate, and in my opinion, this is the most simple. I want that if you have time, check other options, but this one is pretty simple and is accurate, and is easy to remember the formulas. It's easy to remember the quantities. I hope you enjoy this explanation. Okay, my friend, the first one is this. We are going to use a square feet method. A square feet method. Yes, we are going to calculate the capacity of the air conditioning equipment according with the area of the room in square feet. According with the area in square feet. Yes, and we are going to take in consideration if that room is sunny, because there are too much windows, and we are going to add it. Yes, and this method is good for our boats. The structure of our boats is in fiberglass. Remember, fiberglass is a good insulator of temperature. This is a great advantage. And other important thing is that the external color of the majority of the boats is white color. If my boat externally is blue, black, or red, probably you need added 10-20% additionally more BTUs for safety factor. Right now I am going to explain that situation. This situation is with a typical boat in fiberglass, fabricated in fiberglass, with external color white color. Okay, and we are going to use the square feet method to calculate the size of the air conditioning equipment in BTUs, because in marine application the majority of the equipment that you found on the market are rated in BTUs. I have a couple of examples in this video clip related with the price of those equipments. Okay, and we are going to check those prices. I select one company, but the difference in between one company and the other one is 3%, 2%. The prices are basically the same. Alright? Okay, the first one. This is important. Keep in mind this for the rest of your life. 500 square feet of area. 500 square feet of area require 1 ton of refrigeration, or 12,000 BTUs. Look at this. This is very important. 1 ton is equivalent to 500 square feet of area, and this is the same like a 12,000 BTUs. Oh, if the area of the room is 500 square feet, I need 12,000 BTUs. Good. Don't forget. Alright, that's very important. Other important thing. When you calculate the area of the room and the capacity of the equipment for that area, this formula, for the first 2 people in that area, you added per each person 380 BTUs per person for the 2 first people. Oh, if in this area normally are 6 people, okay, you have 2 people. For the 2 first persons, you added 380 BTUs. For the other additional 4 persons, you added 600 BTUs per each person. Right now we are going to do that example. Okay, and if in this area I have included the galley, the kitchen, I am going to add 12,000 BTUs per each galley. That's it. 600 BTUs per each additional person, additional to 2 people. And if the area is considered a sunny area, too much windows, too much glass, you added additionally 10%, because the area is a sunny area. Okay, we are going to repeat. Per each 500 square feet of area, I need minimum 12,000 BTUs, or 1 ton, per each 500 square feet. Okay, that calculation, 12,000 BTUs per 500 square feet, included 2 people, and each people you need added 380 BTUs per person. If I want to add more people, I added 600 BTUs per person. Okay, if in the area is included the galley, I added 12,000 BTUs for the galley. If the area have a lot of windows, 50% of the surrounded area is windows, this is considered 50% or more. This is considered a sunny area, sunny space. Alright, and I added to the total, I added 10%. We are going to solve it a real example related with that. But before we solve the example, the real example in a boat, we are going to check how are the prices and how are designed the equipments, the marine equipments in BTUs for boats. All right. This is one of the examples. This is a self-contained unit. The minimum capacity that you found in the market for a self-contained unit is 6,000 BTUs. 6,000 BTUs, that unit. Okay, that unit, the price is $1,500. And included the thermostat, the grill, and the harness. That's it. And it's $1,500. Okay, it's not too expensive. It's for 6,000 BTUs. Right now we are going to check 6,000 BTUs for what area is good. All right, this is one. The other one, I have a other bigger, 10,000 BTUs. Once again, it's a self-contained unit. $1,530. Practically the same price. For 12,000 BTUs, $1,600. It's not expensive. For 20,000 BTUs, $2,300. $2,300. Self-contained unit. It's good. I like it. All right. And let me check if I want to design a chiller unit. You remember the chiller unit? Yeah, this is a chiller unit, and the chiller units are coming in between 16,000 BTUs until 108,000 BTUs. It's a big range, no? It's a big range of units. The big one is 108,000 BTUs. It's a big unit. All right, those units, the unit of 108,000 BTUs is $22,000, and the unit of 16,000 BTUs is $4,400. This is the price of each one, 44 and 22. All right, those are chiller units. Remember that if the boat is a big boat, I prefer a chiller boat, a chiller unit located in the engine room, and I install air handles in different areas of the boat. In the saloon, in the master room, other air handle, in the guest room, other air handle, in the fly bridge, other 4 or 5 air handles with only one unit. Yes, you need to calculate the capacity per each area. Per each area, you added all of those BTUs, and you calculate the total capacity, and you select the chiller appropriated. This is the most common design used today in the construction of boats, chiller units, because it's efficient. You remember, you install the unit in one place, and you move it, chilled water, no refrigerant, into each air handle. For that reason, the majority of the medium, big, and mega yachts today, they use chiller units because it's highly efficient. It's highly efficient. Okay, my friends. Right now, we are going to check a real example. Look at this. This is the price for the central chiller unit. Remember that the chiller unit have the condenser and the evaporator, and the evaporator is surrounded with fresh water. I explained in details the chiller unit, and those are the air handles. And look at this. Those air handles are in different capacities. Each air, this one, the smaller, is 4,500 BTUs, 6,000 BTUs, 12,000 BTUs, 48,000 BTUs. Yeah. Remember that the air handles, the capacity of the air handles, this plus this plus this plus this, all of them together should be equal to the capacity of the central unit. Yeah. The central unit is 60,000 BTUs. Okay, I can divide it in different air handles. Maximum 60,000. I prefer a little less. I prefer 10% less than the total capacity of the equipment. Alright, that's clear? The addition of all the capacities of the air handles should be maximum 90% of the total capacity of the central chiller unit. Yeah, in order to work in below the curve of efficiency, with good efficiency. Okay, my friends, this is good. I select those prices from a company that I love it. Is Yacht 8 Marine. Yacht 8 Marine. I start to work when I start in this business with that company, and also with Mabru Power System. I love those companies. They have great prices, but the prices in other companies of the market are pretty similar. Normally, I buy my air conditioning equipment, my generators, my windlass, my bow thruster to Mabru Power System and Yacht 8. And both of them, they supply generators, air conditioning equipment, they supply bow thruster, gyros, everything. They are great distributors, and they are those equipments are Webasto. Webasto is a great is a new trade in this type of equipment, in air conditioning equipment, and I install in some cases Dometic, Marine Air. All of them are excellent manufacturers. But for this example, I use Webasto, but the equation is the same with other brands. All right, my friends. Okay, and I have a real example. This example is good. Suppose that I have this Viking yacht. This is a nice yacht, Viking. It's a 58 feet. It's a nice boat, and the beam is 15 feet. And we are going to calculate in this particular example the capacity of the air conditioning equipment for the saloon. In this boat, in this wonderful boat, the saloon have the kitchen, the galley included. You see, the galley here in this area is included in the saloon. This is a great example. We are going to calculate only the capacity of the air conditioning equipment for the saloon, for that boat. Yes, this is a good chance. Okay, and this is the procedure. The saloon, the area of the saloon, according with the information from the manufacturer of the boat, is 18 feet times 14 feet. 18 times 14. It's a rectangle. It's not exactly a rectangle, but the area is approximated 18 times 14. In other words, the total area will be, the total area will be 18 times 14, and this is 252 square feet. You remember the equation that we used before? We said that 500 square feet is equivalent to 12,000 BTUs. Oh, okay, 12,000 BTUs. All right. Oh, how much is 252? 252 is 6,000. It's half. It's half. It's approximately 6,000. All right. Right now I have 6,000 BTUs only because the area, because it's 18 times 14. Okay. All right. The total BTUs, we are going to add it here. The total BTUs will be 6,000 BTUs because the area. And in this saloon, it's supposed that it's designed for 6 people constantly in the saloon. 6 people. Okay, the 2 first people is 2 times 380. 2 times 380 is 760. 760 because the 2 first people. And you have 4 people at 600. This is 2400 BTUs for the 4 additional persons. people. And we are going to add it 1200 BTUs because the kitchen, because the galley. Okay, in total I have 10,360. Okay, I have a 10,360 BTUs in total, but I need added 10% because you remember the saloon is surrounded by a lot of crystals, a lot of windows. This is considered an sunny area. Okay, because it's a sunny area, I am going to add it 10%. 10%. How I added 10% is 10,360 times 1.1, and this is 13,396 BTUs. Oh, this is approximated 14 BTUs. This is a real calculation. I need 14 BTUs for the saloon. And of course, I can do the calculation for the master room, for the guest room. I added all of them, and after that, I take the decision. I want to install a chiller. I prefer a chiller. Or I prefer individual equipments, self-contained for the saloon, self-contained for the master room, and self-contained for the guest rooms. It's other decision. Some boat design. That's your decision, and the decision of the engineers, depending on the configuration of the boat. Yeah, or split units with 3 compressors in the engine room and 3 evaporators. One evaporator for the saloon, other evaporator for the master room, other evaporator with 3 compressors in the engine room. This is other option. In that option, in the split unit, you need pipes with freon in between the engine room and the evaporator. In the chiller unit, I install the central chiller unit in the engine room, and I connect with pipes with water, with chilled water to the handles. All right, that's your decision. But for this particular example, for the saloon, I need 14,000 BTUs. 14,000 BTUs. Okay, I can check. For example, this one. This is for 12,000. This is excuse me. This is for 12,000, and this is for 20,000 BTUs. Yeah, there are 16,000 BTUs. Okay, you can select one. This is a self-contained unit. It's around $2,400 the unit for that saloon. It's not expensive, only for the saloon. Okay, my friends, this is the procedure. And now you select the unit, and now you need to install the ducts and the grills. The ducts and the grills are a little different for marine applications, because basically the ducts and the grills are with the frame in wood, not in aluminum, like this. This is in wood, in order to avoid condensation of water on the edge of the grill. And the ducts are circular ducts, and they are fabricated in a special foam. The foam is a special isolator and is wire reinforced. And this is the charge to select those ducts. This is very important, this information. For example, this one. For 5,000 BTUs, I need a duct of 4 inches in diameter. And the grills, for that specific duct, the discharge grill, the grill that discharge the fresh air, should be 30 square inches, and the return 60 square inches. Normally, the return grill is practically double that the discharge grill. Of course, because the return air is hot air, expand more volume, and you need a bigger grill. In the discharge grill, you need less air. In this particular case, for 5,000 BTUs, you need the duct, the diameter of the duct in 4 inches, and the grills 30 square inches the discharge and 60 square inches the return. Oh, let me check for our example. Our example, suppose that is 12,000. 12,000. Oh, is 6 inches in diameter. 6 inches in diameter, the duct. And we need a grid of 70 square inches the discharge and 130 inches the return. Square inches. Oh, nice. Nice. Yeah, you can select 120 square inches. Oh, 10 by 15 or yeah. This plus this should be exactly the area that you need in the return. Can I order custom grills? Yes. Yes. The majority of the company dedicated to sell air condition elements, air condition equipment, they sell the ducts, they sell the grills and the adapters. The adapters are like this. Elements like this that you convert is something like this. You have the big duct in 6 inches and they have a box like this, and after that divided in 2 outputs of 3 inches. Oh yeah, this is 3 inches. This is 3 inches, and this one here is 6 inches. Ah, nice, nice. You can divide the duct into small ducts. For example, for the guest rooms, normally the guest rooms are located one in front of the other one. You enter with the central duct and you divide it in 2. There are different type of adapters like this, yeah, or adapters that convert the cylindrical duct into square ducts. Yeah, this is carpentry, and this is your design. All right, you need too much imagination in order to route those ducts properly, in order to install with properly brackets, in order to avoid that the ducts move it with the movement of the boat. This is practically carpentry, and normally the carpentries help in the installation of those ducts inside of the boat. This is part of the carpentry: the installation of the ducts, the installation of the grills, and the adapters, the boxes. Okay, this is not complicated. I love this chart. This chart is good. For example, for an 18,000 BTUs, the diameter of the duct should be 7 inches, and it's 100 the discharge square inches and 200 square inch the return, the grill for the return. Yes, my friend, this is not complicated. Look at the material. The material for the duct is basically foam. The yellow one is foam, and this is a plastic wire reinforced. Yeah, and normally those ducts are located inside of the boat, in between the ceiling and the deck. You have those elements should be properly attached. In the majority of the company dedicated to sell equipment, they sell those elements with the adapter, with the brackets, with all the elements necessary to install an air conditioned equipment. My friends, once again, in this calculation, you only need creativity, imagination, and be organized, and other opinion. Normally, when I calculate the air conditioned equipment, I ask different opinions. When I visit Maru Power Systems or Yat 8, they have excellent engineers that help in order to take a properly decision. Probably my idea is a self-contained unit, and they say, no, Alvaro, I recommend you can install a chiller unit and you avoid this and this and this, and this is more efficient. All right, that's good. Normally, in those companies, they have excellent engineers that help in order to take a good decision.